Aloha! Thank you for joining me in this virtual field trip to the Pauoa Flats Ecohydrological Field Site, which was established to investigate hydrological impacts of land cover change due to plant invasion. Let's go to Oahu. The third largest Hawaiian island is comprised of two remnant volcanoes, the Waianae mountain range to the west and the olau mountain range on the east side of the island. Much of the remaining intact native forests on Oahu are restricted to the upper reaches of the watershed. Pauoa Flats is tucked under Ko'onauhuanui, the peak of the Ko'olau mountain range. At 1,600 feet, the site lies at the boundary between native intact montane ecosystems and novel forest community assemblages, which are the combined result of extensive reforestation efforts of the early 1900s and the subsequent spread of invasive forestry and ornamental species. The site is comprised of a paired plot design, with a native forest stand abutting an invaded stand. It is roughly 1,000 meters squared. The native forest represents wet-mesic forest type, typical of older geology and steep terrain in Hawaii. The ground is covered by an indigenous sprawling fern, Dichronopteris linearis, known in Hawaiian as aluhe. The canopy structure is discontinuous, and while mid-stature trees are not uncommon, our plot is dominated by the endemic tree Metrosideros polymorpha. In Hawaiian, this plant is called ohia lehua, and it is a keystone species both ecologically and culturally. The invaded stand is just on the other side of that tree line and has a strikingly different structure than that of the native stand. It is dominated by strawberry guava, one of the most widespread invasive plants in the state. The stand has smaller stem size and higher stem density, characteristic of strawberry guava monotypic stands. Schuba tenardesia adds to the dense understory. Plant matter is almost continuous within the vertical space of the stand. In contrast to the native stand, the canopy is closed. And the soil surface is completely devoid of ground cover. The field site is implemented with an array of sensors, continually monitoring environmental variables and hydrological pathways, such as through fall and sap flow within the study species. This continuous monitoring approach will enable us to quantify various flows within the two forest stands and discern how hydrological differences are manifested by this land cover change. Many thanks to our project sponsors, the Honolulu Board of Water Supply, to the Water Resources Research Center for putting on this conference, and to you for taking the time to visit the Pauoa Flats Ecohydrological Field Site.